Dear students, today we are going to discuss 11th class first topic units and dimensions. The topic we are going to discuss. What we are going to learn in this topic. Units and dimensions is the most basic topic for all over the topics up to 11th and 12th. There is a basic. We have to know what we are going to learn. We have many physical quantities and we have many observations in the nature, right? So whenever you are coming across the comparisons or observations, you're going to come one stronger, one weaker, and one is okay travels more distance, one is travels less distance. Like that, some lot of comparisons there. If while you come across case of physical quantities, while you are comparing the physical quantities, the comparison is most important, required. The comparison can be done in a proper, okay, fixed manner that can be done using units and dimensions. Units and dimensions gives one method of comparing the physical quantities, which is more, which is like okay, less like that. Suppose example, a small kid is there and a parent is there, and if you compare both are compared in terms of height, we can compare. Both can be compared in terms of weight, we can compare. Both can be compared in terms of fatness, you can compare. This comparison can be done using units and measurements. So we have many lots of physical quantities in the nature. All physical quantities, how we are classifying the physical quantities and how we are comparing that, the method of calculation of the comparisons, and using that some advantages, disadvantages that we are going to discuss in this units and dimensions topic. According to units and dimensions, we are classifying the physical quantities into three categories mainly. First one called fundamental quantities, second one is derived quantities, third one supplementary quantities. Fundamental quantities are the quantities which are independent of any other physical quantity. It is same like in our English alphabets, how the A, B, C, D like that. A does not depend on B, B does not depend on C. It is separate individual letters like that. Fundamental quantities which does not depend on any other physical quantities, which you cannot express on other form of physical quantity, that okay, physical quantity we are calling as fundamental physical quantity. Example for that physical quantities are basically we have mass and length, time. These are the most basic fundamental physical quantities which we are calling as independent physical quantities. Next, if we come across a case of derived physical quantities, derived physical quantities are the physical quantities which depends on the fundamental physical quantities. That means the physical quantities which have many number of, that all can be written in terms of mass, length, time. That physical quantities we are calling as derived physical quantities. Example we can come across in the case of derived physical quantities. Example, in this case the example for that one is velocity and acceleration, okay, so on. Many are there, just I am explaining two. Velocity we are expressing in terms of basic term as a definition, distance by time or displacement by time, according to exact nature of vectors. Like velocity is nothing but displacement by time. Displacement we are measuring in terms of length, so it is the length, and time we are measuring in terms of seconds, that is time. So length by time, length is one of the fundamental, time is one of the fundamental. So velocity is a derived physical quantity that I can able to express in terms of fundamental quantity as a length and time here. Similarly, acceleration also one of the derived physical quantity. That acceleration we can write like this. Acceleration is a vector quantity that we can write as velocity by time. So this velocity by time already just written here. Velocity, that means 1 by t into velocity we can write in terms of length by time. So here it is, we have a time here. So acceleration I can write in terms of length by time, 2 times we are getting, that means time square. So what this gives information here, that is nothing but this acceleration is depends on the fundamental quantity length and also another fundamental quantity time. That means I can express these derived physical quantities in terms of fundamental quantities as either mass, length, time, or combination of mass, length, time in terms of division, in terms of addition, in terms of multiplication, like that. That type of physical quantities we are calling as direct physical quantities. Other than these two, we have a separate physical quantities that is called as supplementary physical quantities. The supplementary physical quantities are, example here, these are not comes into physical quantities, these are measuring physical quantities like angle. The angle can be measured in two ways, that is two-dimension measure of angle, two-dimension measurement, and three-dimension measurement. So if you are measuring the angle between the two planes, if you are measuring the angle between two planes, this is one of the plane. If I say this is the one of the plane, if you say these are the this is another plane, if you say this is another plane, if you say the angle between these two, the angle between these two, if you are representing with the theta value varies from 0 degrees to 360 degrees. You know that geometrically. So this is the way I can able to explain that total angle within the two lines in a plane can be varies from 0 to 360. This angle is called as this. The measurement of angle is one of the comes into supplementary physical quantities. Suppose if you come across the case of ice cream cone, if you come across the case of ice cream cone. In the case of ice cream cone, that is which is two-dimension figure, this is one of the three-dimension figure. In this case, the angle inside the plane of the wall, this angle is called as solid angle, that we are representing with omega. This solid angle is also one of the supplementary physical quantities. So we have a two types of supplementary physical quantities. One is angle between the two planes, second one is three-dimension angle. That means this is called as plane angle word. In the place of the two-dimension angle we are calling as plane angle. The three-dimension angle we are calling as solid angle. So these two are called as fundamental physical quantities. Sorry, not the fundamental physical quantity, they are called as supplementary physical quantities. To compare the physical quantities, the physical quantity we are expressing like this. Physical quantity can be expressed, it is the product of quantity of that physical quantity into unit of that. So what is the meaning of this quantity and unit? Quantity is nothing but called as magnitude of the physical quantity. Magnitude of that physical quantity. Unit is representation of that physical quantity. So different physical quantities having different units. Like example, you went to market, you are buying the vegetables in terms of kgs, and you are buying the oil in terms of liters. The kgs and liters, these are called representation of that physical quantity in terms of units. So any physical quantity we are expressing in terms of quantity into unit called as magnitude into unit. The magnitude nothing but number. Representation of that physical quantity in terms of number is called as magnitude. Take an example. Whenever you take in any body, this is the way the force is applying on the body. One person is applying the force on that. How much? 100 newtons. Here, what that physical quantity here? Force is one of the physical quantity. In that, the 100 is the called magnitude. Newton is called a unit of that physical quantity. So, what is 100? Magnitude. What is N? Is the representation of that physical quantity unit in terms of Newton here. Now we are going to discuss system of units. System of units. The units are classified into different systems according to the way we are using that systems, because from ancient days to now we are using different methods to measure that physical quantities, to represent that physical quantities in terms of units and magnitudes. That systems are classified into mainly three categories. We have first one is, in the olden days we are using one of the system called as FPS system. That is, F means foot, P means pound, S means second. And the second one is we are using, that is CGS system. C means centimeter, G means grams, S means second. And another system is MKS system. MKS, M means that is meter, K means kg, S means second. And nowadays we are using one of the latest system that is called Standard International System. So whatever the measuring we are doing in the MK system, same thing will be there in the SS system. But what is the difference between MK system and SS system? That will go in a point now. Then after we go for each system and comparison table and we'll close. So in the MK system, whatever we are measuring the physical quantities, we are expressing the units of the physical quantities. For the fundamental physical quantities only we taken here, only 3 fundamental quantities, that is mass, length, time, at the time of FPS system, CGS system, MK system. So how many fundamental quantities? Only 3 fundamental physical quantities are present at the time of MK system. What are that fundamental physical quantities? Mass, length, time. But when you come across a case of SS system, so that is latest system, according to this one, we have 7 fundamental physical quantities. 7 fundamental physical quantities we have according to latest system of units which we are using. According to this one, the fundamental physical quantities are mass, length, time, 3 already over. Then after measuring of temperature, that we are measuring in terms of theta. That is also one of the fundamental they identified later. And intensity of light, we are using the 2 brackets, we are getting the intensity of light. That intensity of light is also measured in terms of fundamental, that is called lumens, called as intensity of light. And current, we are whatever the current which is flowing through the circuit, that is also we are measuring in terms of some units called amperes. So that is also one of the fundamental quantity. Then after, quantity of matter means whenever you taken the gas in a container, the container contains number of molecules, which contains Avogadro number of molecules. You know that number, whatever we are measuring in terms of mole quantity are going to measure, that mole is also called as quantity of measurement. And other than this one, and we have a measure of other physical quantities, you can check it. We have, how many we got? We got 7. These are the 7 fundamental physical quantities according to latest system. So FPS system, the measurement is very small. Length we are measuring in terms of foot. P means pound. We are used to measure in terms of pound second. CGS system, centimeters, gram second. MK system, meter, kilogram second. And all SS system are similar to MK system. Now, to understand the problems and the doing of the problems, you must understand conversions of CGS to MKS. MKS to CGS conversions is required. So if you understand that conversions, you can be very easily solve the problems. And mathematical, those who are preparing for the NEET students, they won't get much problem in the while solving the problems if you are perfect in the conversion of CGS to MKS, because most of the problems in physics you are going to solve either only in MK system or only in CGS system. So according to options, you have to choose the system which you need to convert. So now we are going to discuss how to convert the CGS to MKS. That means what is the units we have CGS, what is the units in MKS, like some physical quantities how we are measuring, we are going to discuss. Just before we learn all physical quantities having, it can be expressed in terms of units, right? So here, these are some physical quantities we have. Every physical quantity we are expressing in terms of units and represented by a particular letter. The letter A symbolically is represented which corresponding to the physical quantity. If it is derived by any scientist's name, so according to the name of the person is given as a unit. So if you see the examples here, length. Length is we are measuring in terms of meter, that we are indicating the small m, and mass is we are measuring in terms of kilograms, that we are indicating with kg. Time is seconds, like that we have different physical quantity. Temperature, if you come across a type of Kelvin, capital K, Kelvin is one of the scientist name, and electric current is ampere. Ampere is one of the scientists, that's why it is indicated with capital letter K. And if you come across a case of derived quantities also, if you observe that one, force, gravitation force, you know that, which is explained by the Newton's apple falling case, that force is measured, we are measuring in terms of newtons, that's why it is indicated with the capital N. So what are the physical quantities which are expressing unit with the capital letter means, that is indicated by, that is derived by scientists, and the remaining is indicated by small letters only. So it is compulsory that if you are expressing any unit with a derived by scientists, that has to be expressed with the capital letters only. So if you see, you can see the time table. In this we have many, okay, physical quantities. We have frequency, force, pressure. Frequency is Hertz, scientist name, and force, Newton, scientist name, and pressure is Pascal, that is PA, that is Newton per meter square, and energy is joules. Joule is a scientist name, capital letter. Power is watt. Watt is also a scientist name. Electric charge is Coulomb, is okay, one of the Latin name, and electric potential is V. Electric resistance ohm. Like this, we have every physical quantity we have different types of notation according to its derived by scientists or normal way of expression of that physical quantity in terms of unit. Come to the case of some examples. Suppose engines. Okay, we are using the train engines, lot of engines, machines we are using, all are running with the powers. So the power of a certain motors are given 1000, okay, watts, like that. If they given 1000 watts, 1000 watts can be expressed here. The 1000 is called as magnitude, watts is called as the units of that one. So the 1000 number magnitude which we are expressing according to the given table in the side, okay, right side of this one, that is called prefixes values. So here I can write this one 1 into, I can write as 10 cube, I can write one way, or I can write 1, okay, that is, I can write this value in terms of 10 into, okay, 10 square I can write in terms of like this also I can write, and this can be written in terms of, okay, 100 into, so 10 we can write as 10 power 1 also we can write like this. So many ways we can express this physical quantities using this prefix x. This is 10 cube, 10 square, 10 power 1, like that according to this. And if you come across the case of this symbol prefix, if any number indicated with 10 power 1, that is nothing but we are calling as deca, and any number which is represented power is plus 2, this is plus 2, that is called as hecto, and any number which is represented with a cube, that is called kilo, and any number which is represented with a plus 6, 10 power 6, is called as mega, and any number which is expressed with 10 power 9 called as giga, and any number which is expressed with 10 power 12 is called as tera. Okay, so here I can express this power in terms of, okay, kilo, this is kilo, 10, okay, 10 cube, that means this is nothing but 1 into 10 cube, nothing but I can write as simply 1 kilowatt. We can write like this. Now if you want to write this one in terms of hecto, this is 10 hectowatts, we can write. If you want to express this one in terms, sorry, this is in terms of 10 square means here hecto. If you want to express this one in terms of 10 power 1, only 10 power 1, that is called 100 deca. Okay, the 100 decawatts. Like this we can able to express. If you want to express in terms of 10 power 6 megawatts, that power can be written in terms of 10 power 6. If you want to write this one, so here we can write as 0.001 into 10 power 6, I can write. 0.001 means what happens here after 0.3, okay, numbers are there, the 3 numbers here, 3 cancel, again you get the same 1000. So that means this is, I can write this value in terms of megawatts as in terms of 0.001. This 10 power 6 is called as mega, and the units of the power is watts. So this is a way you have to use the prefixes whilst solving the problems and conversions in the problems. So not only that one, while sometimes we have to write some decimal powers. Example, if you come across a case of power, the power utilized by engine is 0.001 watts. Only this is, before we taken 1000, now 0.00. So what way I can write this value? This value I can write as, after decimal we have 3 digits are there, that's why I can write this one as, okay, 10 power minus 3 I can write. That means 1 into 10 power minus 3 I can write, that is watts. So what is 10 power minus 3 called? If you see this one, 10 power minus 1 called as deci, 10 power minus 2 called as centi, 10 power minus 3 called as milli, 10 power minus 6 called as micro, 10 power minus 9 nano, 10 power minus 12 called pico. And these are the, okay, from here to here, these 4 are most important while solving the problem until your completion of second year, okay, and competitive examination. This term will come, milli, micro, nano, pico, these terms will come. So this is 10 power minus 3 means what is the value of this one? That is milli. This is nothing but 1 into 10 power minus 3, that is nothing but 1, okay, milliwatt is the answer for this question. So you have to express this in terms of milliwatts, or you can also express in terms of micro, in terms of nano, in terms of pico. So this is most important. You have to buttify this table and you have to understand the conversion of that one physical point or unit to another way of unit conversion in terms of kilo mega, either positive zeros or negative zeros, like that. Now come across the supplementary physical quantities. Already we discussed there are two supplementary physical quantities we have. One is called plane angle, second one is solid angle. Plane angle means between the two planes. This is one plane, this one plane. If you say between these two, whatever the angle is, that's called solid angle, plane angle. That is between the two-dimension angle. So if you come across here, this is I taken one of the circle here. The circle, this is x-axis, this is y-axis. In between that, if the particle is rotating in a circular path, like if you say this is the angle made by that particle at any instant of time, that angle we are measuring in terms of theta. This angle is called as plane angle. This plane angle we are measuring in terms of units called as radians. Theta is radian. The theta value varies from 0 to 360 degrees. Now here similarly, if you come across the case of second one, solid angle. What is solid angle? It is angle made by three-dimensional plane. So you can say the three-dimensional angle measured by spread area is called as solid angle, that we are measuring in terms of steradians. That is, the steradians we are using the letter. Some books they will give omega, and or also we are using ohm symbol. This is the symbol, you can see this is ohm symbol. So here you need to understand the concept here. If you come across a case of steradian three dimension like football, you can see the football, there is a patches are there on the football. This is the one of the patch, I can say this is one more patch, you can say like that. I can divide this football into number of patches like that. So the patch which you taken, that patch makes subtends an angle at the center. It makes some angle. That angle, how much it is making, that we are calling as solid angle. That is three-dimensional angle called as solid angle. Why we are discussing this one? Because this is most important in the competitive examination for the mains level questions can be solved using this one, because we have electrostatics topic is there, light topic is there, sound topic is there. Sound is propagates all the directions, how the sound is producing, how the sound is propagating, how the light is spreading, and how the electric fields are spreading. That concept we are explaining based on this solid angle concepts. Next topic is dimension formula. What is dimension formula? It is the most important topic in the units and dimensions. Dimension formula is one of the method of writing a physical quantity in terms of mass, length, and time. That means while you are writing the dimension formula, we are saying formula while you are writing, that express that mass as a capital M, length as a capital L, T as a T. So the physical quantity which you are expressing in terms of mass, length, time, and whose powers. What is the meaning of powers? The physical quantity. This is mass. If you say nothing is there, means you can take it as 0. If anything mass is present, you can write as 1, 2, like that according to physical quantity. This is called as power. So any physical quantity which is raised by certain power in terms of fundamental quantity is called as dimension formula. That dimension formula how to write, and after writing methodology if you learned, and using the dimension formulas, we have a lot of applications. That application based problems also we have in the examinations. First I explain how to write the dimension formula. Any physical quantity dimension formula can be expressed in terms of mass, length, time. This is the procedure you have to follow. That is, mass you have to indicate M, length L, time T. If powers are nothing is there, that means you have to rise with the zeros, and you have to close this one with a closed bracket. Square bracket you have to close it. This as per the rules and regulations, MLT. So dimension formula can be applicable for the 3 physical quantities only, more than 3, and we are not going to write. Some we can write, but only thing is some applications cannot be done using more than 3 fundamental quantities dimension formula. So here any physical quantity which you are expressing in terms of MLT whose powers are raised by certain value number is called as dimension formula. So I'm writing some examples here. You take the examples. The example for I'm writing the dimension formula for the velocity. Velocity is one of the derived physical quantity. First, before writing any dimension formula, that dimension formula physical quantity, first you have to convert into fundamental quantity, because velocity is a derived quantity, so you cannot write directly in terms of MLT. So for that I have to write in terms of formula based. According to formula, you know that velocity is equal to displacement per time. Displacement is one of the measure we are measuring in terms of length, so that we are calling as L, and time, T is called time. Time we are measuring in terms of capital T in dimension formula. So if you observe this one, the L, okay, T in the denominator, if you make it upwards, it becomes T minus 1. Here L is, okay, in the power of the L, nothing is there, means you can write as 1. So if you want to write exactly the dimension formula of this one, you can write as M0 L1 T minus 1, we can write using square bracket. After getting practice of this one, no need to write, if which is having 0 power, no need to write, directly you can write the velocity having dimension formula is L1, that is LT minus 1, we can write. So this is the way you have to practice some physical quantities to, okay, how to convert into fundamental quantities that you have to practice. I will take one more, acceleration. Acceleration nothing but velocity by time. Now velocity is not a fundamental. To write the dimension formula, compulsory you have to convert into fundamental. So velocity I convert again. Okay, 1 by t I taken common here. Velocity I am writing again. Distance by time I am writing. So the formula will becomes distance by t square. It becomes. Now the acceleration dimension formula I can write. The distance we are measuring in terms of fundamental as a length. Time we are measuring as a fundamental as a capital T. The power of the t is raised by 2, that is t square. Now t square in the denominator, if you make it to numerator, it becomes t power minus 2. So the dimension formula for acceleration will becomes LT minus 2. The dimension formula for this one becomes LT minus 2. This is the way you have to write the any physical quantity, derived physical quantities in terms of dimension formulas. Now we will discuss the examples. I taken 3 examples here: force, physical quantity, torque, and power. We'll write in dimension formula for that one, as well as we will try to write the units of that one in terms of fundamental quantities. So as for the practice of the first, if we come across a case of force we are indicating with the letter F. So before going to that, you have to know the physics formulas. So if you are completing all the formulas in the textbook, you can do it this physical quantity dimension formulas well. So before that, you have to learn some formulas which you know aware. And force is that one of the physical quantity that we can write in terms of mass into acceleration is the basic definition of that you have to know that. Now this I can write mass is called nothing but one of the fundamental physical quantity, so you can't convert it again. But acceleration is one of the direct physical quantity just before we done the conversion of this one. So I can write mass into acceleration, we can write in terms of distance by t square just before we done. You can check it previous one. Now m into s into t square. What is m? Mass, fundamental physical quantity, and s, fundamental physical quantity. Time is also fundamental physical quantity. So whenever any physical quantity, first to write the dimension formula, you have to convert into fundamental physical quantities like this using formulas. Now I can write this one as m s into denominator t square. If you make it upwards, it becomes t power minus 2. Now I can write the dimension formula for this one, f equal to capital M. Okay, m is nothing but means that is 1, m1. S distance we are measuring in terms of length, power is 1, and time is raised by minus 2. So the dimension formula simply we can write mlt minus 2 is the dimension formula for this, okay, physical quantity force. Now what are the units of this one? If you want to write the units, actually force is explained by Newton's, already we discussed in the previous, that we are indicating with the Newton n letter, scientist name Newton n. And this is the one of the unit. Also we can express in terms of fundamental units like this. If you see the formula of this one, fundamental units like this is the formula I can take. And m, mass can be measured in terms of kg, and the distance can be measured in terms of meters, kg meter. Time can be measured in terms of second minus 2. So this is a way you can write the any physical quantity units in terms of actual unit and in terms of fundamental units. So you have to understand the conversion of these units also. We'll discuss in the applications of the dimension formulas how to convert this later. Now this is first example. So what is the second question? The second question is torque. Torque is one of the force. It is also one of the force, but this is called as rotating force. If the fan has to rotate, what is required? Torque is required. And if the vehicle has to move on the road, what is required? Force is required. So force makes the body to move in a straight line. Torque makes the body to rotate. in circular path. So torque is one of the physical quantity, and the torque dimension formula we can write in terms of, if you know the formula, you can write it. That will come in the as we are going into the topic. So torque is equal to, I can write as R cross F according to exact nature of vector based. So simple based we can write as F into R we can write as. So in this case, what is F force? Force dimension already just to be done in terms of fundamental quantity. This is, so we already done. Just you can write it directly here, and S, that is T minus 2 into, right, into what is this R? R is called as radius vector we are calling, that is the distance. R is also radius vector, that is distance. Circular motion having radius, any circle having radius, that radius is R. So that R we are representing in terms of length as a distance S. So if you solve this one, M into S 2 times, we are getting S square, T minus 2 we are getting. So this torque we can write in terms of fundamental quantities as, that is M power 1, and that is S is nothing but L power 2, and time is nothing but T power minus 2. This is the dimension formula for the torque, that is ml square T minus 2 is the dimension formula for torque. Next one, if you come across a third example, in the third example, what I can write? The third example is given physical quantity is power. Power we are indicating with the letter P. Many engines are working, okay, making the bodies to move, rotate like that, having some power, right? So more water motors all are having power. That power, physical quantity, we are defining like this. Many types of definition statements are there. I am writing one of the formula, that is force into velocity. The formula for power we are having force into velocity, you will understand later. So the force formula in terms of fundamental quantity already we done, that is ms T minus 2 already we done, and also velocity also we done just before. Velocity is what we done, that is distance by time, distance st minus 1 we done into. So this if you write in order, m into s how many times? 2 times ms square, and this is T minus 3 you are going to get. So the power dimension formula we can write as m1, that is L square, and T minus 3 is the dimension formula for power. So this is a way you have to understand how to write the dimension formula for each physical quantity, okay, for the derived quantities in terms of fundamental quantities. Now if you come across units of this second one, torque, because first one already force we are indicating with the newtons, and also fundamental as kg meter per second square. But in the case of torque we are in terms of, we are measuring in terms of Newton meter, because basic formula is force into distance we written. Force we are measuring in terms of Newton, distance is meters, so Newton meter is one of the unit of that. Also we can able to express this torque in terms of fundamental like this, using this. What is this fundamental mass? How much is there? Only one, that is called as kg. Distance is square is there, that means meter square. Time, that is nothing but second minus 2. So this is a way we can express the torque in terms of its own unit and in terms of fundamental unit. Similarly, the power is also we can able to express. How we can able to express the power? Okay, fundamental quantity is mass. Mass means nothing but power. Actually we are measuring in terms of watts. Power we are measuring in terms of watts, 10 watts, 20 watts like that. But in terms of fundamental quantity, mass means we are measuring in terms of kg. S means distance, that is nothing but length. Length we are measuring in terms of meter square, because we have a 2. Time minus 3, that is nothing but we can write as second minus 3. So this is the way you can write any physical quantity unit in terms of actual unit or in terms of fundamental quantity. Here we are discussing some examples which regarding the physical quantities. Some physical quantities having, that means that some group of physical quantities having same dimensions but different units. Some physical quantities having constant values still have a dimension. Some physical quantities having only constant value, no dimensions. That some examples we are going to discuss, because these questions are going to be asked in the competitive examinations. So if you understand the comparison of physical quantities in terms of dimension formulas, that will be useful for the competitive examination questions. So here I taken some example of each part. Here we are taking the physical quantities, any two physical quantities which are having similar dimension formulas. but different units. Similar dimension formula, different units. Come to the case of first example, torque versus work. Torque is one of the physical quantity. Just before we discussed, torque is formula we are writing in terms of R cross F. This is one of the rotational force we are calling. This is the formula. And work is also one of the physical quantity. That work is the formula for that. Work is equal to force into displacement. This formulas you will get it in the while you are learning the actual topic. If you already learned that, you can understand easily. So this is one of the vector quantity. This is one of the scalar quantity. So here these two physical quantities are different, torque and work, and but both are having same dimension formula. How you can say dimension formula torque already we just before we done. So the dimension formula for this one is already just before we done, that is ml square t minus 2 is the dimension formula for the torque just before we derived previous. Now what is the dimension formula for the work? Work is also we can derive directly here. Force is one of the physical quantity. The dimension formula for the force just before we done. So the dimension formula is mlt minus 2 is the dimension formula for this into what is this called distance. Distance dimension formula, that is we are indicating with L. So L how many times? This is one time, this is one time, totally 2 times. So work dimension formula will becomes ml square t minus 2. So if you observe both physical quantities, both are having same dimension formula, ml square t minus 2, ml square t minus 2. But if you come across the measure of the torque we are measuring in terms of Newton meter is the unit of that one according to its own parameter of measuring, and work is one of the form of energy. Work done is one of the form of energy that we are measuring in terms of joules. So Newton meter is different and joules is different. Both are units are different, but the dimension formula is same. Similarly, go to the second example. In the second example, angular velocity versus frequency is given. Angular velocity also called as angular frequency, that is we are indicating with omega. The formula for this one is 2 pi by t. 2 pi by t is the formula for this one. 2 pi is constant. So according to our discussion of this one, the limits of the dimension I will explain. So here 2 pi is not having dimension here. That is nothing but we can write as 1 by t. 1 by t means that is t minus 1. So t minus 1 is one of the second minus 1 is the unit of that. This t minus 1 also we are calling as frequency, that we are indicating, we are measuring in terms of hertz. Next, if we come across a case of frequency, the frequency is also one of the physical quantity. The formula for the frequency is 1 by t. So angular velocity also we are getting 1 by t. The frequency also we are getting 1 by t. Both are having same dimension formula, t minus 1, t minus 1. Both are having same dimension formula. But the measuring of this one will be little different. What way? The omega we are measuring in terms of radians per second is the unit of this. Radians per second, this is the units of this one, which one? Angular velocity. But frequency we are measuring in terms of hertz. Only the actual units are different, but the dimension formulas are same. This is another example. If we come across a case of last example, pressure versus energy density. So third example, pressure versus energy density. What is pressure? Pressure basic formula is force acting per unit area. The force dimension is ml t minus 2, already just before we done, by area. Area is nothing but, that is we can write area in terms of pi r square if you take in a circular area. If you take in square plate, L square, B square, like that we can write. So area always becomes square of the length, it becomes square of the length. So I can write here the area dimension formula is equal to L square. So here L, 1L we can cancel according to mathematical procedure we can follow here. P is equal to, we can write as ml, make it upwards, L minus 1, T minus 2. This is the dimension formula for this problem. Sorry, pressure. Right? Now go to the next one. What is the given? Next one is energy density. What is the meaning of energy density? Energy density we are indicating with the letter U. This is always we are calculating energy per unit volume. Unit volume. Energy is a form of work. Energy is form of work. Just before here, work is measured in terms of joules. This work is always we are measuring in terms of energy. So this energy is nothing but work. Work done per unit volume is called as energy density. So what is the work dimension formula? That is ml square. T minus 2 is the dimension formula for that. And volume. Volume nothing but, if you take in a cube, the cube contains three sides, length, breadth, height. So what is the volume of the cube? If L is the length of this one, L is the length, breadth of this one, L is the height of this one. Then volume of this cube, it becomes equal to L cube. Now what is the area becomes L square. Area of this one becomes L square. So volume is 3 times of length. 3 times of length. Volume is 3 times of length means I can write as that is L cube. Now if you write this one, L square, L cube get cancelled. Again, what you are going to get U is equal to M L minus 1 because denominator we have 1 minus 1 T minus. So if you observe the both dimension formulas, both are having same dimension formulas. ML minus 1, T minus 2. Both are having same dimension. But if you see the units of this one, pressure we are measuring in terms of pascals, kilopascals, like that we are going to measure Newton per meter square like. But energy density we are measuring energy nothing but joules, okay, per unit area, cubic meter, okay, per unit volume. Volume means we are measuring in terms of meter. So joule per meter cube is a unit of energy density. So both are having different units but having same dimension formula. Like this, we have many physical quantities are there which are having similar dimension formula of different units. You have to practice of all the number of physical quantities in the tabular column for competitive examinations. According to dimension analysis, constants not having dimension formulas, but we cannot say that 100%. Some of the physical quantities which are having constant values also having dimension formulas. The physical quantities which are having dimension formulas compulsory having units also. The physical quantities which are constant may have a dimension formulas. So if you come across the case of examples here, we taken most important 3 examples. They previously completed exams also, they will ask, you have to remember. First one, gravitational constant. Gravitational constant we are indicating with the capital G. The formula for this one, gravitation formula, F equal to G into, that is m1 into m2 by r square is the formula here, where G is called universal gravitation constant, m1, m2 are the masses, r is the distance between the two masses. So simply under the two equal masses, if you are calculating the gravitation force between the two masses, I can write this is simply G into m square, both are same masses, if you take an m square by r square, I can write. So if I write this one in terms of G value, if you want to calculate, G is called universal gravitational constant. It is one of the constant. The value of this one is given, you can check it here, 6.674 into 10 power minus 11, that is nearly 6.67 into 10 power minus 11. You can use it while solving the problems. The G value, okay, formula from this I can write as F into r square by m square, I can write. So the dimension formula for this one, if you apply here, that is dimension formula for the force, you know that is mlt minus 2, I can write, into dimension of r. R is nothing but distance. The distance we are measuring in terms of length, so I can write as L square by m is nothing but mass here. Mass we are measuring in terms of kg, or in terms of m we are indicating, that is m square, I can write. So here according to cancellation, here m we can cancel, 1 m left here. Remaining, if you write the formula for this one, universal gravitation constant dimension formula, if you written here, m, denominator m, if you make it upwards, it becomes m minus 1. Here L is there, here L square is there, L into L square becomes L cube, and this is the T power minus 2. So the dimension formula for this one is m minus 1 L cube T minus 2. This is the one of the physical quantity which is having constant, okay, value, having dimension formula, and also negative mass dimension formula. Compared to all the physical quantities, this is one of the physical quantity which is having negative. The power of the mass is raised by negative. Okay, this is one of the most important factor you have to remember. So this is the value of this one. G value is equal to how much? 6.67 into 10 power minus 11, having value. And units of this one, what are the units? Mass means, this is mass, that is nothing but we can write as, okay, m minus 1, that is we can write in terms of formula, use this formula, G formula, this is the formula you can use it. Force means newtons, that is Newton meter square by kg square. You can use this formula, unit of this formula. So this having dimension formula, constant having dimension formula as well as units. Similarly, go to the Planck's constant. Planck's is one of the chemistry also, we got the Planck's. Okay, so energy in terms of, we can write in terms of Planck's as h mu. Light travels in the form of energy packets as h mu. Mu is called frequency, that is nothing but we can write as, okay, 1 by frequency, nothing but 1 by t, I can write. where H is equal to what I can write? E into T we can write. So what is E here? Energy. Energy is form of a work. Already just before we discussed energy, always measuring in the form of work. So work into time. So what is the dimension formula for the work? M L square T minus 2 just before we done into T. So if you calculate this one, what you are going to get, this H Planck's constant dimension formula is becomes ml square, that is minus 2, this plus 1 becomes T minus 1. So this is the dimension formula for Planck's constant. The Planck's constant value H is equal to how much? You can see here, that is 6.625 into 10 power minus 34. 6.625, that is 6 into 10 power minus 34. Okay, is that, and the units of this one in terms of, if you written, that is joule per second, that is joule second is the unit of this. One more unit of this. So if you observe the dimension formula, ml square T minus 1. So this is the one of the constant value which is having dimension formula as well as unit as well as constant value. Like that, we have a speed of the light also. Light travels with a speed how much? 3 into 10 power of 8 meter per second. Speed means velocity. Velocity means LT minus 1. So it is also having constant with dimension formula along with the units. Like this, you have to understand some constant having dimension formulas also. Now we will discuss the limits of dimension formula. The application of the dimension formula when you are using, we have a limit survey, because all the cases we cannot apply the dimension formula. First, some constant not having dimension formula. Example like the value of pi. Pi is nothing but 22 by 7, 3.14. It is not having dimension formula. And like that, some constant not having, most of the constant not having dimension formula because it is a number. But some constant having dimension formulas. Next, second, mathematical functions not having dimension formula. Mathematical function means we are using integrations, differentiation, logarithms, and limit functions. Lot of mathematical functions we are using. Whatever the functions we are using, we cannot apply the dimension formula to that functions. So like integrations we cannot apply, trigonometry we cannot apply, limits we cannot apply, and logarithms also we cannot apply like that. So exponential functions also we cannot apply. So these are the limits. We can't apply the dimension formula for certain things. Not only that one, last one, if you come across, the dimension formulas cannot indicate the it is a scalar or vector. It only gives the formula for that one, but it cannot indicate the either a scalar quantity or vector quantity. Clear? So these are the limits of dimension formula while we are applying the solving the problem, and some relations we are finding in the applications of the dimension formula. Okay, next class we are going to discuss what are the applications of dimension formulas. In the last point, we can go for one of the constant, like one of the supplementary quantities we have. The supplementary quantities we discussed as angle, and plane angle and solid angle we discussed, right? Plane angle and solid angle. So these two are having units but not having dimensions, because this is indicating with the theta, and this solid angle we are indicating with omega. These two are having units, radians and steradians, but not having dimension formula. So like that, we have to understand some physical quantities.